Okay, let's talk about the scalability in ACP. As I mentioned in the previous lecture, it's highly recommended that you deploy your ACP servers behind a HTTP load balancer. You can do this in many different ways. For example, you can deploy your own load balancer, such as Nginx, or you can use load balancers available in public cloud, such as an application load balancer in Amazon Web Services. Or you can containerize your ACP servers and deploy them to Kubernetes and allow Kubernetes to do the load balancing for you. If you use a load balancer, it's highly recommended that you terminate an SSL certificate on the load balancer to enable HTTPS. We will explore this in more details later. Also, all these ACP servers that you see on this diagram are copies or instances or clones of the same ACP server. And we do that to cope with more load. Normally, as the amount of load or the number of requests received per minute goes up, you create more instances of the ACP server automatically. We do that normally through either the Kubernetes or through auto-scaling groups in Amazon Web Services or through scaling sets in Azure, for example. So normally, as I said, we configure our production in a way that as the amount of load or number of HTTP requests per minute goes up, we create more and more copies or instances of the ACP server automatically to handle the load. If your ACP servers are stateless, you can create as many copies as you want and put it behind a load balancer. However, if your ACP servers are stateful and they maintain session, you need to make sure that they share the session, because if, say, your ACP client sends one request to ACP server or runs the ACP agent within the server for the first time, then a session is created. But that session by default is stored in the local memory of the ACP server. The second time ACP server sends a request to the ACP servers, the load balancer sends that HTTP request to the second ACP server or to the second copy of the ACP server, because that's what load balancers do. And because every ACP server stores the session information in their local memory, the second copy of ACP server has no access to the session information of the first copy of ACP server, and therefore when they return a response, the response has no relevance to the first request. And that is why we need to share the session across all copies or instances of your ACP servers. And we do that with a session store. ACP supports two types of session stores. One is Redis, the second one is PostgreSQL. You can install your own instance of Redis, or you can use Redis as a managed service on, for example, Amazon Web Services, and configure your ACP servers to use that. I will show you how we do that in Visual Studio quite soon. And then ACP server will store the session information, which includes your conversation history, in that session store, not in its local memory. And therefore, all ACP servers will have access to conversation history, and their responses will be relevant to each other. As I said, you can use either Redis or PostgreSQL. Redis is good for short-term persistence but fast access. Basically, Redis is a distributed caching system. Or if you want to persist the conversation history for a long time for whatever reason, you can use PostgreSQL. In this table, you can compare the options. The default option is always memory store, which is used by default, and you don't need to do any configuration to use it. However, it's only good for single instance ACP servers. If your ACP server is going to scale out, then you cannot use memory store unless your ACP agents are stateless. It doesn't support high availability. If you restart your ACP server, you lose your session information, and also every information that you may have in the session will expire after a given amount of time. In case of Redis, it doesn't come as default or by default. You need to either install it or use managed Redis service in some public cloud, for example, Amazon Web Services. And all the instances of your ACP servers must access the same instance and same database of Redis. It supports HA deployment. HA refers to high availability. So by having Redis, you will have high availability with fast access. And also after some time, the information that you have in Redis will expire. In case of PostgreSQL, again, you have to install it separately, or you have to use PostgreSQL as a managed service in Azure or in Amazon Web Services. And again, all the copies of your ACP servers must have access to the same database of same PostgreSQL instance. But then when you have it, you will have high availability in your deployment with persistence. Postgres is ACID compatible. ACID refers to atomicity, consistency, integrity, and durability of transactions. That's a type of transaction you will get in schema-based databases. Let's go to Visual Studio and I'll show you that how we can configure Redis and PostgreSQL. So I'm in Visual Studio. If you clone the GitHub repository of this course, there will be a directory called Session Storage. I have two copies here. One is server with Redis, one is server with Postgres. You can look at this code and basically understand how we configure Redis or Postgres and use it in your own ACP server's code. To use Redis, obviously you need to install the Redis library, and you do that with pip install Redis. Also, when you import your SDK server, you must import Redis store class as well. Then you will create an instance of the Redis class, and you will provide the address of your Redis server, the port, username, password, and database name. In this example, I have hard-coded these values, but obviously for username and password, you have to read it from a secret manager or from encrypted config file. Then you know how to create an instance of server and how to create an agent. That is not any different to what we have learned before. However, when you run your server, you have to give a value to the store parameter. Store parameter in our case is Redis store, and then you pass your Redis object to it as well, like this. And if you run it, it will always store your session information in a Redis instance. In case of Postgres, you need to install Postgres library, which is this one. And then instead of Redis store, you will import PostgreSQL store. And from the Postgres library, you will import async connection. You will create a connection. In the connection string, you must provide username, password, host, and database name. And then when you run your server, your store this time will be an instance of PostgreSQL store. And you don't have a store parameter here. You have a connection parameter, which is then this. You provide this and a table name. Again, as I said before, you have to import the username and password from a secret manager, and you shouldn't hard code it in your source code.